Hello, testing, testing. Is my mic still speaking today? I don't think so. Okay, very nice. Hello, hi Kuni Panda. How you doing? And nothing is being displayed right now. Anyways, hello, good morning, or afternoon, or evening, wherever you are. We are doing more Microsoft question review today. We're doing all the questions that has given me a hard time during the past 2 weeks. I've got the list of questions written down. We're actually really close to finish reviewing. We only have 2 more questions and that's it. I'm thinking about tomorrow moving on to Google interview questions. I think that will be fun and challenging. Google is pretty notorious for having really hard questions. Kuni Panda says, sup bro? Hello, I'm doing good. I've been getting some really good sleep recently. I don't know if you know, there's a sleep app called Pokemon Sleep. There's one day I got like 9.5 hours of sleep. My sleep score was like 100%. And then I saw Pinsir, which is really cool. The really good Pokemon only appears when you get really good sleep. Anyways, we are on Leetcode 253. Leetcode 253. Bam. Meeting rooms 2. And it is a premium problem. Fantastic. Leetcode 256. Okay. 253. Okay, meeting rooms 2. Why can I not navigate to it? Really? Oh, there we go. That's the website. Okay, given an array of meeting time intervals, where intervals I is equal to start end, return the minimum number of conference rooms required. Okay, this is really difficult. Yeah, I remember this. Kuni Panda says, I'm Snorlax in Pokemon. I like to sleep. Yeah, Snorlax is maybe the sleepiest Pokemon in there. Yeah, the Pokemon Sleep game is actually centered around Snorlax, so you're the center of the game, man. Okay, there's been a particular way that I've been doing this problem right with a priority queue, where I'm first sorting all the intervals by start interval and then the end interval. But there was another method, right? Where you're returning the well, you first break up all the intervals into their starts and ends, right? And then you sort all the starts, you sort all the ends, and then you go through each of the lists. I think what you do is you mark at any time how many intervals are active at any given time. You know, add 1 if 1 starts, delete 1 if 1 ends, and at the end you keep track of your max active intervals and then return that. Yeah. So how do we do that? Okay, this is gonna be the first time I'm trying this, but I'm pretty sure you can. Perhaps just sort. Put them onto a list and sort them, and then keep taking the next one that comes next in sequence, and Yeah, track how many intervals are active at any given time. Okay, that sounds like a plan. Sure, let's go with that. So we put all of our starts and ends into separate lists. That's what we'll do so far. Sort starts. Okay, so starts is equal to new start where the start is equal to what? Intervals dot length. Okay. That is the wrong syntax. Int. Okay. We'll also have another array for the ends. Ends is equal to also length intervals dot length. So for every single interval in intervals, we add the corresponding one into starts and ends. So starts dot you know what, for convenience, I'm lazy. I think I'm gonna do a list of starts. Integer. And then list of integer ends. So it's convenient to add stuff inside. New array list. Likewise for here, yay. Cool. Starts.add. So now I can just do starts.add interval 0 and then ends.add interval 1. Man, this is actually the first time I'm trying this technique for this problem, so I don't even know if this is gonna work. And then you sort the starts and ends, so collections.sort starts, collections.sort ends. Okay. And then now we go through all the starts and ends, right? We pretend that they're all like all in one sequence, I guess. The reason they're in two separate lists is because we want to be able to differentiate between the starts and ends. I think I've seen other people approach this method the same way by making like a priority queue sorted by the first element of an array, but the second element of the array is like 1, -1, depending on if it's a start or end, and then that's how they process it. But this is fine, I think. It's kind of like processing the starts and ends while we merge it, you know, but not really. Okay, so while, what's the while condition? We're reading all the starts and ends, right? Is it like index? Start index is equal to 0. It's in ascending order, right? Okay, that should be right. Okay. So these are the indices that we will use to read the two lists. Int start I, int end I is equal to 0. Okay. So while the start indexes are in bounds, intervals dot, well, less than starts dot size or the end I is less than ends dot size. So basically, if either of them have stuff, keep going, you know, and then we'll keep taking the least one because it's in ascending order. Okay, so okay, the current start is equal to starts. Well, we need to. Okay, we've done merging questions before, right? We need to first check if the start is in bounds first. So if start I is less than starts.size, then you just return start.get start I, the index, else you return integer.max value. Yeah, because we're going to take the least one, right? Integer.max value is always going to be skipped over, most likely. Unless the other one is integer.max value too, but I think that's super rare. The current end is equal to, if the end index is less than ends.size, then ends.get and I, else return integer.max value. Okay. I feel like that's right. Alright. I should probably do a sanity check really quickly. This is getting kind of confusing already. So if start is less than end, meaning we will process the start first. Process start first. You know what? Let's just print stuff out first. Let's do a sanity check. So system.out.println starting room at start, and else, meaning we process end first, end time first. Out.println end room at plus the end. Okay. Oh, we have to increment their pointers to end I plus plus start I plus plus, and in the end we return an int apparently. So we'll just return -1 by default. Yeah, again, this is just sanity check. Start room at 0, 5, end room at 10, 15. I'm so confused. What is the chronological order? 0, 5, 15, 0, 5, 10, right? Yeah, okay. End room at 20, 30. Okay, these are all in chronological order. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, we should be on the right track then. 2, 4, 7, 10. Okay, that's for sure, right? Okay, sure. So now we can process all of the, you know, what do you call this? Checkpoints, important checkpoints of our timeline. And now we can keep track of how many intervals are active at any given time. Fantastic, okay. Int active intervals is equal to 0. Oh, okay, so anytime we start a room, our active interval should increase. Plus, right? We should also have another variable to store our max active intervals. Max active intervals is equal to 0. And then whenever we increase our active interval, we also update our max active intervals. Max active intervals is equal to math.max, the current max active intervals. This name is so long. Relative to our current active interval. Alright. And then whenever we close a room, we decrease our active intervals. Yeah. And then we just return our active intervals. Oh, no. We return our max active intervals because all the rooms are shut down at the end, right? Hey, let's go, it worked. Woo. Awesome. Why is this so slow? This is really slow. Is it because of the sorting? What is the runtime of this? So for sure it's n log n time over here. Iterating through all the starts and ends should be n time. Yeah, so n log n time. Alright. Yeah, alright. I mean, I'll take it, n log n time. 3 millisecond runtime. What do they do here? Okay, they use arrays, and they just do arrays.sort. For int I is equal to 0, I less than start.length. So if you're using a start, room plus plus, wait, what? Less than start.length else, and end index plus plus. Return rooms. Wait, that's what I'm doing. Okay. Does it really make that much of a difference to use? Wait, they never decrease the rooms count though. What are they doing here? So they're iterating through the starts. If index I is less than n, then rooms plus plus. Else end index plus plus. They never stop the rooms though. I mean, either way, there should be n time for both, right? Is the difference actually just sorting it based on arrays? You know, I'm straight up gonna copy this. Is it actually that much faster? Sorting the start ends as arrays of starts, and this is pretty much what I was doing in the beginning. Starts, ends, okay. Well, start I is less than starts dot length, end I is equal to end dot length. This is also dot length. This becomes that. Else integer.max value. This becomes dot length. This becomes bracket notation. Okay. Is this how it works? Dang. It was the difference between arrays and lists. I guess a list is like a wrapper class around an array, huh? So it'd be slower. So native arrays are faster, like way faster. Dang, bro. All right. Good to know. I'll take it. Dang, 90%. You know what? I'm gonna star this question. This is an interesting question. I definitely want to review it again in the future. Next up, we have Leetcode 348. Leetcode 348. Oh, design tic-tac-toe, which is also a premium question. No. Three, four, eight. Bam. I'm gonna get rid of that question. I mean the solution, which isn't even right anyways. Assume the following rules are for the tic-tac-toe game on an n-by-n board between two players. A move is guaranteed to be valid and is placed on an empty block. Once a winning condition is reached, no more moves are allowed. A player who succeeds in placing n of their marks in a horizontal, vertical, or diagonal row wins the game. Implement the tic-tac-toe class. Tic-tac-toe n initializes the object the size of the board n. Move indicates that the player with ID player places the cell row column of the board. The board is guaranteed to be a valid move, and the two players alternate in making moves. Okay, it's guaranteed. Guaranteed to be a valid move, okay. So they're never going to try to put a token on a spot that has already a token on it, okay. So we don't have to validate that. 0 if there is no winner after the move. 1 if player 1 is the winner after the move. Or 2 if player 2 is the winner after the move, okay. Okay, I somewhat remember this. There's no need to count every single row and column or diagonal at every single move, right? We can pre-count. Yeah, we can pre-count how many are in each row or column. Since the board is like finite, right? N by N board. Okay. Okay. I think for the sake of a tic-tac-toe game, it's still useful to store, you know, the board layouts. I know in the solution it doesn't, but I think it's useful. So we'll have our board here. Sure. And we will initialize our board int board is equal to new int n by n. Yay. Okay. We will also have an array storing all the counts of all the rows. So rows counts, and then columns counts, I suppose. Okay, and then our upper diagonal, I guess. Upper diagonal counts. And then lower diagonal count. Yeah, we will pre-count everything, so it will be relatively fast to check, you know, if we have a win or not. So rows counts. So just to be clear, the format of this will be the row number, comma, and the player number. Yeah. This will be the column number and the player number. Okay, so rows counts is equal to new, so n, because n rows, and then 2, yeah, 2, based on the players. And then columns counts is equal to new int n, also with 2. Yeah, okay. Upper diagonal count and lower diagonal count will start off at 0. Heck yes. Okay, I feel like that's basically it for our initialization. Okay, what happens if we move? Row, column, player. Okay. So let's update our board. I feel like that's important. Row, column is equal to the player. Okay, let's update our rows counts. Rows counts. So the current row at the current player. Wait, what's the index of what could player be? Player is 1 or 2. Oh, okay. Maybe we should make this a 3 then, so we can mark down stuff more easily. We can just put the player index in. Sure. Is equal to, well, plus plus, yeah, plus plus. It should be default 0, right? Hold on. Java 2D array integer default value. Default value of 0. Okay, perfect. That works in our favor. So we can just do plus plus. That's good. And then likewise, the columns will plus plus as well. The column player plus plus. Yeah. We'll also need to update our upper diagonal count. Okay, there should be a way to quickly tell if it's an upper diagonal, right? Like this one, 0, 0, 1. Oh, okay. The rows and columns are the same. If row is equal to column, then upper diagonal count plus plus. If, I guess else if, no need to check it again, else if, okay, what happens if it's like this? I remember there's a way, right? Row column. So the row will be 0, 1, 2. Column will be 0. Oh. Row plus column is equal to n minus 1, basically. Board dot length minus 1. That works, right? So 1, 1. I just realized there should probably be an if as well, because the middle one could affect both diagonals. And then here is 0, 0, 1, 2. Okay, that makes sense. Then lower diagonal count plus plus. We should probably store n too. It's more convenient. Int n. This dot n is equal to n. N minus 1. Okay. So if either of these are, equal to n, then we return the player. Sure. If board so here we check for win. If this is equal to n, isn't this now just a bunch of or statements? Or columns counts. Columns counts is equal to n, or upper diagonal count. Wait, we don't differentiate if this is the same player or not. Okay, that's problematic. No. Should this be a list too? Sure, new list is equal to new int 3. Okay. Upward diagonal count with the corresponding player index plus plus. I'm so paranoid. We have not sanity checked any of these. Or if for diagonal count player is equal to n, or lower diagonal count player is equal to n. That's all the cases, right? Feel like that's all the cases. Return the player. The other player can't possibly score a win on our turn, right? There's no way. Okay, let's run. Return player. Oh. Else you return 0 if there's no winner. Dark Phoenix says, hello. Hello, how you doing? Null pointer exception. Board. Cannot load from object array because... Wait, what's it say here? This dot board is null? Oh. Do we never initialize it? Oh, shizzle. No, I did the constructor wrong. It's this dot board. This dot row counts. This dot column counts. Yeah, I forgot all the this dot keywords. Dark Phoenix says, good ho, how about you? I'm good too. I got lots of sleep the past few days. I scored 100% on Pokemon Sleep, which is nice, and I saw a pincer, which is a nice surprise. Man, I was so close to catching the pincer too. I remember I used the bonus biscuit and a great biscuit, which was super effective. It had one more friendship slot left that was untouched, and then it was full, so that kind of sucked. Oh look, it kind of worked. Hey, it worked, let's go. I am a genius. Cool. Thank you. Okay. Let's see, I'm looking at my list of problems to do now. You know what? We're actually done with all the questions I have written down. We finished every single Microsoft question that I put down for review. So I guess we can move early today to system design study. Yeah, okay. Let me get out my notebook that I use for taking notes for this. Bam. But yeah, how are you doing today, Dark Phoenix? How's your day going? I'm gonna switch to my system design page. Downloads. Alex Shu. Okay. Well, bam. Okay, we are still learning how to design YouTube. It's been so long, we're still here. Dark Venus says, good, it's been a weird day. Oh, how so? Mitchell Doorbor says, I'm second. Hey Mitchell, how are you doing? We're on system design now. We're learning how to make YouTube. Okay, so we've gone through all this part. So again, when a customer on a laptop, phone, or whatever TV device is streaming a YouTube video, they're usually streaming it through a CDN, which is kind of like a cache server. They just choose the cache server that's closest geographically to the user, so they can communicate with it really fast, and then everything else like uploading videos, I don't know, updating your video description, any other API call is done through API servers. Okay. This is the workflow for uploading a video, right? Dark Phoenix says, it's not letting me in my Steam account 30 minutes later. Tried again. Some of my games were gone, and then my Discord wasn't working, so I had to call tech support. Dang, that's rough. What's up with that? Is the Steam account issue and your Discord issue linked? So is it your computer that's not working? That's kind of rough. Sorry to hear that. Okay, so apparently this is how you upload a video. The user gets directed to a original storage, like blob storage. Blob storage is like storage with no format. So they upload the video here, and then there's some transcoding servers that read the video from the blob storage, and it tries to convert it to a, streamable format, like MPEG. Maybe the user uploaded the video in MOV format or some other crazy format. The transcoding servers converts that format into like MPEG, some streamable format, and it also separates out into multiple resolutions. When it's finished, it uploads the job to a completion queue. The completion handler servers read from the queue one by one, and then it also updates the video's metadata. marking it down as, processing complete in the metadata DB, which is fronted by our metadata cache for fast information retrieval. I think while the user is uploading the video too, it also goes through the API servers and does an initial metadata update as well. And then after they finish transcoding the video, they put it into a storage as well, and then put it onto a CDN for people to stream from. Okay, very cool. Dark Phoenix says, my computer's working just fine. I think my little brother tried logging into my Steam. IDK, what's going on with Discord? Oh, okay. Yeah. Discord works kind of weird on my Mac laptop too. It works perfectly fine on my Windows, but sometimes it just takes forever to load or open on my Mac. I don't know why too. This is the exact same thing. That's the exact same thing. Okay, right, so streaming video. Just get to the correct CDN. Yeah, this part was kind of confusing me last time, right? I was like, how do they know which CDN to go to? Apparently it's a combination of DNS, a third-party CDN service, and the front end to decide which CDN the user streams from. Dark Phoenix says, but I'm gonna go see you later. Yeah, all good. Have a nice day, man. Okay, design deep dive. Okay. We were learning about DAGs, right? DAGs is a directed acyclic graph model. It's a way of so this is kind of like the video transcoding stage. When they convert it to a streamable format and do other work, they actually do just more than converting it to a streamable format. They do a bunch of stuff in parallel, and this graph represents what they do. For example, you can process the video and the audio and the metadata in parallel. And in the video, you can also parallelize some of the tasks here, like, I don't know, checking inspection. I'm assuming it's like checking the video for, I don't know, violence or copyright stuff, transcoding it, extracting a thumbnail from it, putting a watermark on it. Yeah, and then you assemble everything at the end. Yeah. Video encoding can also be done in parallel with multiple resolutions. Okay, this one's the really, really annoying part. So much steps. Okay, I'm looking at my notes right now. What the heck does preprocessor do? This is how they handle the DAG nodes. Okay. Preprocessor, apparently it splits the video into a bunch of GOPs. Yeah, GOPs, aka just segments of a few seconds long. Okay, and then it caches all the GOPs in its own memory, so other stages can keep referencing back to it from DAGs or GOPs in case they want to retry or something. So they pass all these tiny GOPs or tiny video chunks to the DAG scheduler. What does that do? Apparently it splits all the DAGs into stages of parallel tasks and stages of parallel tasks. Okay, so this is like one stage, this is another stage. Stages of tasks. Okay, and then it passes it into the resource manager over here. What does that do? Apparently it consists of 3 queues, the task queue, worker queue, running queue. Okay, so the task queue is the task with the highest priority. Worker queue is, probably the worker with the highest availability or resources remaining or something. Writing queue, apparently it pairs up all the workers to their tasks. Yeah. I imagine it sorts them based on... actually, I don't know. Task/worker info into the queue. I imagine it probably has some timeout or something. What if one job, one worker or task just clogs the entire thing? It probably has some timeout thing, right? Yeah, okay. And then the task scheduler also... Resource manager... Okay, and then it allocates all the tasks onto the corresponding task workers. Okay, yeah. Task workers are these random servers that do jobs. Okay. And then they output the encoded video. Very nice. There's also temporary storage, which stores, I don't know, commonly used metadata in a cache. And then video/audio and blob storage. Okay. Cool. Now we have system optimizations. Next, we will refine the system with optimizations, including speed, safety, and cost saving. Okay, this is the new stuff. Now, I haven't read this part very well. Parallelized video uploading. We can split a video into smaller chunks by GOP alignment. Okay. This allows fast resumable uploads when the previous upload failed. The job of splitting a video file by GOP can be implemented by the client to improve the upload speed as shown. Okay. Right, so we process the GOPs in parallel. Place upload servers close to users. Another way to improve the upload speed is by setting up multiple upload centers across the globe. Yeah, this is similar to like CDNs, right? You place the servers geographically close. Okay. This is kind of like data centers, basically. Okay, sure. Parallelism everywhere. A loosely coupled system and enable high parallelism. I forgot what loosely coupled means. What does loosely coupled mean? Loosely coupled. So, okay, individual components depend on each other to the least extent practicable. Practicable, okay. Okay, sure, loosely coupling. Oh, by the way, I forgot to mention, this is probably the segment of the stream where I talk the least, because sometimes I'm just writing notes. So, components... minimally dependent on each other, okay. Minimally depend on each other. Very nice. Okay, what does that mean here though? The output depends on the input of the previous step. This dependency makes parallelism difficult. We introduced message queues. Ah, okay. Okay, sure. Original storage, download module, encoding module, upload module. CDN. Okay. Before the message queue is introduced, the encoding module must wait for the output of the download module. Also, the encoding module does not need to wait for the output. Okay. Okay. And also the thing that's outputting, right? It doesn't need to wait for the availability of the next thing too. Okay, sure, that makes sense. Download module, encoding module. Sure, okay. Safety optimization, pre-signed upload URL. To ensure only authorized users upload videos to the right location, we introduce pre-signed URLs as shown. Wait, what the heck is a pre-signed URL? To ensure only authorized users upload videos to the right location, we introduce pre-signed URLs. Okay. Pre-signed URLs. That's what I'm wondering. The generated URL is then given to the unauthorized user. What is pre-signed URLs? Temporarily grant access to Amazon S3 objects without requiring users to have AWS credentials or permissions. So they give temporary credentials, basically. Used to provide short-term access to private object. Okay. SigV4, okay. You know what? Time to chat GPT some stuff. Chat.openai. What is pre-signed URL? Okay, so it gives temporary access, I guess. Let me write this down. Pre-signed. So it's a link that gives temporary access. Okay. It includes a signature that is created using the service's access key and secret key along with expiration time. Anyone with the URL can access the resource until it expires. Okay, without needing direct access to the storage account, this is useful for sharing files securely or enabling clients to upload files directly to storage. Oh, okay. So the security is in the expiration date only? What if a malicious attacker uses it? Like, is it only protected by the expiration date? So if a malicious attacker gets this URL, they can get access to. The only security feature is the expiration time. Okay, so the only security feature Okay, so cool. The only security feature is the expiration time. All right, cool. Pre-signed upload URL. Okay, so this is for uploading. User post upload, they give you a pre-signed URL. Okay. Okay, so this is for uploading the video to the original storage, so I guess it protects the original storage. Yeah, I guess the alternate is you just have one link to your original storage, right? That means anybody can access it if they know the link. And you're kind of screwed if a malicious user gets their hands on it, right? In this scenario, if the malicious user gets their hand on the pre-signed URL, then yeah, they can upload to it for a short amount of time, but after that time, they're just locked out. Okay, I see. Sure, our API servers returns the pre-signed URL. Okay. And then it uploads the URL. Okay. Protect your videos. Okay, these are copyright systems. AES encryption, okay. Visual watermarking, okay, sure. How do we reduce the cost? Right, so we only put the most popular videos on CDN, right? Everything else we don't use CDN. Yeah, only serve most popular videos on CDN. Otherwise, use video server. Error handling. Upload error, retry a few times. Split video error. Okay, sure. API, okay, just keep retrying, right? Resource manager, queue down, use a replica. If one node goes down, replace cache, yes. Use another slave, okay, yeah, master and slaves, wrap up, okay. Scale the API tier. Okay, scale the database, sharding. Both require uploading, encoding, and streaming. Live streaming has a higher latency requirement, so I might need a different streaming protocol. Lower requirement for parallelism becomes small chunks of data are already processed in real time. Takes too much time, is not acceptable. Okay. Cool, I think we are done with designing YouTube. Awesome. Okay, I think that's enough for today. Okay, thank you everyone for coming. Thank you, Dark Phoenix. Thank you, Owen Davis. I see people in the chat. I am probably streaming tomorrow, I think. Okay, thank you everyone for coming. I appreciate. See you guys tomorrow. Bye. Is anybody streaming right now? Can I rate anyone? Nope, absolutely not. Okay.